But again, you're sketching. I didn't ask you to sketch these, but today we'll sketch some more. But when you're sketching, the key to when you do a phase shift is to figure out where it starts. Start marking your graph at that point. And make sure your increments is your period divided by 4. And just put those tick marks for those increments. You don't have to worry about anything else on the page. So if you could check what you have here, we have an amplitude change. So we have a vertical shrink, it's less than 1. You actually have a frequency of 1/2. So that's saying I want half my curve. So you've got a horizontal stretch by a factor of 2. Okay. Phase shift. Phase shift is C over B. There's your B. So watch your fractions. Keep change flip. So it's going to be 2 pi over 4, which reduces to every pi over 2. Where does one cycle start? Make sure you can do this. Just normally we go from 0 to 2 pi. That's where your unit circle is, your circle. So start it equal to 0, start it equal to 2 pi. 9 pi over 2. If you add 2 pi, if you add 2 pi, take 2 pi and add pi over 4.
Pi 18.
18 over 4? Yeah, just reduce it. This guy here, remember, amplitude is always measured in a positive value. The negative gives you a reflection. Again, here's your B. So your frequency is 4. You have a horizontal shrink. You have a horizontal shrink by a factor of 1/4. You have a phase shift in here. You're moving to the left. Pi over 4, C over B. And make one cycle. What so far? I didn't ask you to graph those. Some of those were a little complicated, so I didn't ask you to graph those. But just so that you get the hang of, my biggest thing is you can make one cycle.
Is it negative pi over 4?
Yeah.
Okay.
I had it simplified, but for some reason when I picked up the pen, it moved.
When you use the light blue, it's really hard to see.
It is? I'm sorry. Mr. Schaefer has my light bulb, has had it for a while, and he keeps promising to put it in. As soon as I get that, it'll brighten this up.
I'll talk to him.
Aha, thanks, because I talk to him a lot. And say, where's my light bulb?
I'll talk to him.
Okay, now, follow the same pattern. Your amplitude didn't change. B is 2 pi, so your frequency is 2 pi. So use your rule for your period. Find your period. Your period is 1 radian. So it was a shrink. It pushed it in. Normally you go to 2 pi. 2 pi is 3.14 radians. So 1 shrunk it in. If I was going to graph this, every period is a 1. I would just separate these into 1, 2, 3, 4, 5, 6. I wouldn't bother putting my angles on. These are your radians.
I didn't take 5.
You didn't get 5 pi over 2. So did you take this and set this equal to 0 and to 2 pi?
Yes.
Okay, so you added, did you get this one? 1 over 1/4? So I know this is very, you can barely see, I can barely see this. So you're going to add pi over 2.
I got it.
You got it now?
No, he just thought that, because he didn't see that 2 pi x equals 5 pi over 2.
Okay.
He thought that 5 pi over 2 was the answer.
Right. Okay,
No. No, I don't get how you got it.
Okay, so convert this, right? Convert this. This is a plus. It's just not appearing this way. This is an equal in here. Okay, so now convert this. So add this. This gives you 5 pi over 2. There's your 5 pi over 2. So 2 pi x is equal to 5 pi over 2. And you're going to have to solve for x, so you're going to divide by 2 pi. 2 pi over 1. Keep changing, flip this. So the pi comes out, and you get 5 over 4. It's the same as like when you convert to a radian measure or degree. It goes back and forth. Just watch your fractions. Okay, let's see how these equations went. There's no answer. When did my answer come out? Let's see if it's on my paper. That's weird. Alright. So let's talk about the first one. Okay. Here's the answer to the first one. I don't know why these didn't come out. I probably caught the picture area when I put the answer out. Did you get this? Anybody not get this?
Wait, why is
Why is it negative?
Negative because here's your resting point halfway. You went down first.
It shouldn't be 2x.
Yeah.
It's in 4 pi.
Yeah.
It's in 4 pi. Okay.
Like, do you see?
So
how
this
the
is
x-
2 pi. So it should just be what, a half?
1.
Let's do 1.
1.
Because there's 2.
Okay.
Do you see what I mean?
Yeah, this just must have had a mistake in this. So it's 1. I agree. 1. Everything else look good?
Yep.
Okay. How about this guy? This one is supposed to be... I pasted it right out of the book. I must have just missed the part with the formula in it. Is that good? Okay. Again, find your resting point. Make sure you find your resting point, or your midline, as they call it.
I couldn't see the ticks, so I wasn't.
Yeah, sometimes
Yeah, so
they're a
I-
little difficult to see.
That's why I put -4.
And that's fine. That's fine. Well, -4 for your amp. Oh, this one here?
Yeah.
Okay. Only because, yeah, you have to find your resting line.
Yeah.
Yeah. Sometimes they are very difficult to see on these.
Yeah, the ticks.
And it's always like confusing. They say -6, so this guy down here is the -6.
Yeah, so it's like.
Let me see
Oh,
what this one
weird.
says. This one says, so let's see that one. So again, we had a period of 1. We reflected it, and we dropped it 6 down. Or maybe 5 down, I'm not sure. 1, 2, 3, 4. It looks like it went 5 down.
From
Yeah,
1.
we'll see.
From 1 it was.
From 1. Oh, there's the +1. Yeah. Yeah. There's the +1. And 74. Did I give you 74? Yeah. Y equals, this one had a reflection. And they told you these were all cosine. This way you didn't put any phase shifts in there. Because if we didn't tell you cosine or sine, you'd be trying to put a phase shift in here. And I mean, you can do it. You get multiple answers to this.
Yeah, because I put a phase shift and I just put in the calculator.
Mm-hmm.
It looked exactly like that. So.
Right, but then you did a sine curve though, right?
Yeah.
Yeah, because they wanted you to do cosine. The directions for this part said cosine. But if you did a phase shift with a sine, that's fine. I usually don't ask you to do a phase shift in an equation because it's a little more difficult.
Only sine has phase shift?
Well, no. The directions for this said
Oh.
use the cosine equation.
Alright.
Then the second, and that's fine. As long as you did it correctly, that's fine. And then this one said do a sine curve. So this one should be is that right? We've got 2 in here. We went down. We did 1, 2. 76 should say y equals 2 sine 1/2 x. Okay, because this again is 2 pi. So it took 4 pi to complete 1 cycle. Amplitude change of 2. And you didn't have 78, no. I think this one had a phase shift. Pi over 4, I think, because you went. This is 2 pi, so that's 180, that's 90. So it started right here in the middle at pi over 4. If you couldn't see it, I get it. It's difficult to spot the tick marks. I'm sure when I made the copies, they came out worse than it looks up here.
see it. I don't even see
Yeah,
it.
so if
Yeah,
you
that's
had
what I'm saying,
pi,
'cause I just saw the 3 at the top, and I thought that was the end.
right, and it's deceiving because this means that's the 2, that means that's the 3. But
Yeah,
as long as as long as something matches what you think it is, I'm fine with that. I like these because they were good equations, but they don't, I have to copy them out of books since you don't want to use your books. So they don't always come out as nice.